Just to note that I'm going to present a few different research studies together today, just a part of those research studies. And this is in collaboration with colleagues at NIE and NTU. So Fuyu Kwok is actually listed, I think, in the program as a PhD candidate, but she did just finish her doctorate, so she's actually Dr. Kwok now. And Professor Annabelle Chen is at NTU in the psychology department. And so what we wanted to do was to look at, I know we've kind of had a few talks now, and I agree with all the presentations where we're saying that phonological awareness is important, but perhaps a little bit overemphasized, particularly across languages as we learn more and more about reading processes and dyslexia across languages. But that said, I'm going to focus on phonological processing skills because they've been so important and because we often think about them when we're thinking about diagnosis. And particularly, we wanted to look at phonological processing outside of a Western monolingual context in which all of these theories and models have been developed and in which a lot of the assessment tools have also been developed and normed. So I'm just going to I'll give a brief introduction. I know we've talked about this in a number of talks, so we have a general appreciation about what phonological processing is, but I wanted to define it in a little bit more detail here because that's the focus of this presentation. So we generally think of phonological processing as phonological awareness or this metalinguistic awareness of the sound structure of the language, and that's one component of phonological processing. So according to the conceptualization of Wagner and Torgerson and their colleagues, they include that skill under an umbrella of phonological processing skills, which also includes two other skills. And those two other skills include phonological memory, or the ability to temporarily store phonological information in a short-term memory storage, as well as the rapid retrieval of verbal labels for symbols. So these could be anything from colors to... Okay, sorry, is that better? Okay. So retrieval of phonological codes for symbols is the third type of skill. So I'll talk a little bit about each of these particular skills and how they're measured with different types of tasks. But first I did want to remind ourselves that phonological awareness itself is something that develops over time. So it's not just one set skill, but it has a developmental trajectory and involves a set of skills that become more sophisticated over time. And so we know that generally there's this developmental pattern which is something that we see within all children, or majority of children, and across multiple languages. Although there's a little bit of debate about the exact sequence, we generally see that children start off with an awareness of rhyme, and then they become more aware in terms of smaller units of sound within words. So syllables, and then onsets and rhymes, and then finally phonemes. And so this, and within each of these unit sizes, we see that children develop more sophisticated abilities, first starting with the ability to blend these units together, and then the ability to segment or take these units apart. And so Motes and Tolman describe this developmental sequence with the types of things, types of tasks that children can perform at different ages across this early childhood stage. So generally around kindergarten, children do, as I mentioned, start with the ability to understand, hear, match rhyming patterns. And then they are able to do things at the syllable level, so they can count the number of syllables in words in kindergarten, and then by the end of kindergarten, they're probably most of them are able to delete syllables from words, so they can say cowboy or parsnip without one of those pieces. And then when children enter primary school, generally most of them will start to develop some awareness at the phoneme level. And so this starts out again with being able to say what are the initial sounds of words, and then they're able to blend different phonemes together to create a word, then to count the phonemes in words, and then to tell what all of the phonemes in individual words are. And then most children then, by the time they get to primary 2 or 3, are able to do things like manipulate phonemes so that they can remove phonemes initially at the beginning of words, and then sounds at the ends and the medial parts of words as well. Okay, so keeping that in mind, I'll look at each of the 3 phonological skills that I described before in terms of the types of tasks that we typically use to assess these skills. So these are examples from the CTOP, which is the assessment that we used in our studies. And here we can see that we can test children's ability to blend or to delete either syllables or phonemes. And so the first example, what sound do these words make, is a typical blending type of task. So children hear a set of syllables and have to blend those together to create a word. The second example, say spider without saying der, is a type of deletion or elision type of task. So remove part of a word and say what's left over. So spider without der is spy. And each of these types of blending or deletion tasks, the items start out a little bit easier at the syllable level, and then they get more difficult where children have to remove smaller units of phonemes. So these are your typical types of phonological awareness tasks. For rapid retrieval of verbal labels, often we use these rapid automatized naming types of tasks, so serial naming tasks, which Denkla and Riddell were the first to discover that even children who haven't learned their alphabets yet, their ability to name colors, a small set of colors rapidly in time, are generally poorer at that type of task when they have dyslexia versus children without dyslexia. And so now we see that this is a fairly robust measure of children who generally have difficulties with learning to read also do poorly on these types of tasks. And then finally, for the skill of phonological memory, we also use measures such as repetition tasks, where children are given a sequence of things like digits, and they have to just repeat the digits in the correct order. And then over items, there's a larger span of digits that they have to recall. We can do the same thing with words and non-words as well. So words start out small and get longer over items. Okay, so why is this all important? Why do we want to measure phonological skills? Well, we know that there's a huge body of research that says, particularly in English, there's some evidence that phonological awareness, phonological skills may be causal in the initial stages of learning to read in an alphabetic language. And it's related to and significantly predictive of reading scores across other languages as well. Secondly, we know that poor phonological skills are related to learning difficulties. So children with dyslexia often will perform poorly on these types of tasks, and that's a pretty robust finding. There's also a convergence of these findings across languages, as well as neurocognitive support that the areas of the brain which support phonological processing are found to be different or anomalous in individuals with dyslexia, both in terms of the activation patterns in those areas as well as structural properties of those areas. So structural differences correlate with how well people do on these types of blending tasks, for example. Okay, so all that said, despite all the evidence, and we've seen a lot of presentations here today and yesterday, that phonology isn't the whole story. We know that both within languages and across languages, there are suggestions that there's other difficulties besides phonology that individuals with dyslexia have. So within languages, we know that not all children with dyslexia have phonological deficits. We also know that across languages, particularly in alphabets that have shallower orthographies, phonological awareness is not as much of a concern. It's not as much of a difficulty as much as fluency is. And then in non-alphabetic languages, we see that there's a difference in terms of the prevalence rates of subtypes. So we've seen some interesting talks already on subtypes. And other types of dyslexia involving rapid naming or orthographic processing are more prevalent in non-alphabetic languages, as well as other types of skills like morphological awareness, orthographic awareness have found to be more related to reading in these types of languages as well. Okay, so what we wanted to find out then was whether the phonological skills within individuals in Singapore, so individuals who are, for the most part, as we've seen, bilingual, or at least bilingual, perhaps trilingual in some cases, would they show difficulties with phonological processing for individuals who have dyslexia? So we were looking at a group of children with dyslexia, and admittedly our sample sizes are a little small, but I'll go through some of the data with you from these three groups that we have. So our first group is children with dyslexia, average age 8.5, and then we also have another group of their peers, typically developing readers. And then as another contrast, we have a set of adult skilled readers who are university age students. And so for each of these participants, we measured with the CTOP2 their phonological awareness with the elision, blending, and phoneme isolation subtests, a composite of the rapid symbolic naming skills with digits and letters tasks, and then phonological memory with non-word repetition and memory for digits. For children, we also measured segmenting non-words for phonological awareness, and for them we used the TAPS for memory for digits. And then for each of the participants, the adults also were assessed for reading skills with the British Ability Scales, and children with the Wide Range Achievement Test for reading. Okay, so what we found essentially was that when we just compared these groups with simple ANOVA, we found that there were no group differences between the adults, the children, either the typical or dyslexic children, in terms of their phonological awareness scores. But they did differ in terms of rapid naming. So the adults were generally better in terms of their rapid naming scores than both the children's groups. And then the adults were also better than the dyslexic children's group in terms of their phonological memory scores. So I'll show some of that data, but what I wanted to do is look, instead of just showing some means, just look at some of the individual scores and see what is the spread of scores across these groups. So looking first at phonological awareness, I want to show the composite score. So this is the combination of elision, blending, and phoneme isolation scores, first for children and then for the adults. Okay, so for these plots, we see that each bar represents a participant. The top graph is for our children with dyslexia group. The bottom is our children without dyslexia. And these are, again, the composite scores, which are standardized measure. So they have a mean of 100 and a standard deviation of 15. So from that, we would expect that the average range of scores is lying between 85 and 115, which is outlined here with the dotted lines. So when we look at the group's performance, we see that the dyslexic individuals, there's a number of them who actually are performing within the average range. There's a few who are below or just at the baseline of the average range. But we also see when we look at the typical readers for children, again, there's some who score within the average range, but there's also several who are well below the average range. And then when we look at the adult data, so again, this is one participant per bar, and this is our average range from 85 to 115 on the Phonological Awareness Composite score. We see that there are a number of adults who are within the average range, but also a significant number who are below or well below the average range on these phonological awareness types of tasks. Okay, so for phonological awareness, at least for these composite scores, we see that both for children and adults, there's a number of typical readers who fall below the average range, and there's also a number of dyslexic readers who are within the average range for phonological awareness. And this is just summarized here. So this is for the adult group. We see our phonological awareness composite scores across the group on average are pretty much at the near the baseline of average. And this contrasts with the adults' scores on the rapid naming composite score and the phonological memory composite score. So both of these composite scores across our sample of adults was within the average range. And then if we look at each of the subtests within those composite scores, so these are all our phonological awareness scores, rapid naming, and phonological memory. Again, we see both phonological memory and both RAN subtests are within the average range for the group, whereas we see particular difficulties with blending, a little bit with phoneme isolation, but particularly blending test is difficult for our typically developing adults. And then if we look at the children's data using the same format for the plot, we see that, again, their phonological memory scores are within the average range for both groups. So up top is our dyslexic group, and down the bottom is our typically developing children's group. We also see that their rapid naming task scores are within the average range. Where they show difficulty for both groups is with blending, whereas phoneme isolation for most of them was average for both groups. And then blending non-words was also difficult, and particularly so for the dyslexic group. Okay, so delving just a little bit deeper, if you can bear with me, what we wanted to do next was to find out, is there something about the blending task that makes it particularly difficult? Because we saw that this was difficult across all our groups. It didn't just differentiate those with dyslexia, it was also difficult for adults. So we used item analysis to look at those blending scores. And with this type of analysis, what we can do is look at each particular item on the test. And for each item, for like question number 1 or 2 or 3, we can say, how difficult is that item across our participants? So that's our difficulty index across the x-axis. Items that are not very difficult, this indicates about 90% of people in the sample get it correct. If we had a test in a classroom and we had a difficulty index of 10%, that means that only about 10% of the students are getting it correct. It's a difficult item. For discrimination on the y-axis, generally items that are higher are better at discriminating individuals who are high scorers versus low scorers. Okay, so if we look at our data, I'm going to show the children's data first, but this is actually from a different set of data because we had just a small sample of children in the study here. We're looking at data from a different longitudinal data set, also primary 1 students. And here what we see is that the earlier items, items 1 to about 9 or 10, are fairly easy. Most children are getting these correct. So they're not very difficult. Whereas the later items, so out of 34 items on this task, the later items are very difficult. For most children don't get these correct. And then we see the expected pattern where the middle items are about 50%. You know, half of the sample are getting these correct, half of them get them incorrect. And of those middle items, most of them are pretty good at discriminating between those who are high scorers and low scorers. So somebody that got number 18 correct, for example, is most likely a high scorer. If they got this item incorrect, they're most likely a low scorer on this task. There was one anomaly, so, oops, sorry. Item number 8, so I can play this for you.
What word do these sounds mean? How?
Okay, it's not playing.
What word do these sounds mean? How?
So item number 8, they're actually asking what word do these sounds make, and it says hammer. So I just wanted to display these items because I wanted to see if there's any feedback from people in terms of any insights that you might have. We essentially were looking for items that might point out particular pronunciations that might be difficult or different in standard English versus what children or adults might hear in Singapore. It didn't seem to be the case. We'll just move on to the next one. So this is the same type of analysis, but with the adult sample. So the same items on the same task for blending words. We see a little bit more scatter here. So the easier items, many of the easier items are less difficult, and the later items are more difficult. But we also see that there's not as good discrimination in these middle items. So individuals about items like 12, 15, 17, individuals who get these correct may or may not be high scorers on this particular task. And so I was going to play these, but just to show you the words, these involve words like mad, so the person would hear what sound did these letters make, what word did these sounds make, mad, saw, nap, bone, and miss. So again, there doesn't seem to be a consistent pattern here in terms of the particular items that might be difficult. Okay, so finally, just to get to the last piece, we also looked at phonological awareness scores and phonological processing scores in the relation to reading with correlation analysis. So this is looking at the adult sample. So here we found that when we correlated their word reading scores with the blending phoneme isolation, RAN, and phonological memory, that blending phoneme isolation, RAN tasks were all significantly correlated with adult word reading, and their memory scores also showed a trend for significance. So these are actually the raw scores that were where we partialed out age. And then when we look at the whole group, both the children and the adults together, we still see that rapid naming is significantly related to word reading. However, blending phoneme isolation are no longer significant, and again, phonological memory shows a trend for significance. Okay, so just to sum up, we found that generally compared to the Western normative sample in a monolingual sample, that our sample's performance on phonological awareness was relatively lower. And this was specific to the phonological awareness tasks. It didn't occur for phonological memory or rapid naming. And this, I would say, follows from research evidence, and we talked a little bit about the double deficit hypothesis, but there's also been some follow-up research that rapid naming and phonological awareness, although they're considered as phonological skills, are actually independent types of skills. And so Powell and et al. Found with their structural equation modeling that when phonological processing, which included phonological awareness and phonological memory tasks, was entered into their model separately from these RAN tasks, that this type of model was a better fit than a model which included all of these items as one latent factor. Secondly, there's a recent intervention study that also supports this independence of phonological awareness and RAN skills, where they found, van der Stappen et al. Found that there were differential treatment effects when they used a phonological awareness intervention versus a rapid naming intervention. Phonological awareness affected primarily spelling, RAN intervention affected primarily word reading speed, and that was differential, so you didn't see the opposite effects. We also found that the raw scores for phonemic blending was correlated with reading by adults, while the rapid naming scores were correlated with reading within all groups. And so just the kind of a takeaway message here is that when we think about dyslexia and following a phonological core deficit model, we often will use phonological assessments as part of a diagnosis within our test batteries. But we need to use caution if we think about using standard or composite scores for those tests. And we also should consider that these other measures for rapid naming and phonological memory may be just important or more important in terms of the diagnostic step within different contexts. Okay, and these are some references. I just wanted to say special thank you to our participants, as well as DAS for helping us find some of them. Also our institutions and agencies that funded our research. I'll give a selfless plug here. We had hoped to have, the adult study is actually ongoing, and we had hoped to have some adult dyslexic data to present to you today, but we're having trouble finding them. So if anyone in the region has any ideas for where we can post some recruitments to find some adults that have dyslexia, this is some of the behavioral data I showed you, coupled with an imaging study. And then one last thing, if you don't mind. I also wanted to note that there's a relatively new association, which Dr. Uno had actually, I think, was one of the originators of this whole group, and which is now an official association for research, for reading and writing in Asia. And the first conference for this organization occurred in 2017 in Hong Kong. This year, in February, it was held in Japan. And next year, the annual conference will be held in India. So just for your information, if you want to go to the website for ARWA, I think generally the call for papers and presentations will come around in November. And just to a little highlight, we also are aiming to have this conference here in Singapore in a few more years, so probably 2021. Okay, so that's all I think I have to say. So thank you.